Hello everyone. Today we are going to talk about Altair and data visualization with Altair. This presentation is just a quick overview of what Altair can do. So my goal is that at the end of this presentation, you will know the syntax and be able to create your own plots. At the beginning, we will talk a bit about the special and simple grammar and the differences to conventional graphic libraries. To motivate you why we should learn another visualization library, I will loosely talk about the Grammar of Graphics, a book written by Wilkinson that is very influential about how we visualize and think about data. The idea is that if you want to represent a data set graphically, you have several building blocks from which a chart can be assembled. Understanding the ways in which these elements of visualization interact is important when using Altair. Now, to create a plot, we start with our data set. Usually it's a pandas data frame. And if not already done, we transform our data set. And based on our data, we then decide what we actually want to see. So for example, a line chart, scatter plot, area, or bar chart. How the whole data is represented. This is called mark. Then as you figure out how to encode the relevant data. So to be more exact, we decide what belongs on the x-axis, what belongs on the y-axis. This is basically the essential part, deciding what we actually want to show, or deciding what belongs on the graph. Then you determine how to scale your data set, and then you define a guide so that the person that's looking at your graph knows what's in front of them. And this type of data visualization breaks down into the process breaks down the whole process into individual steps. And Altair is exactly built on this concept. So the core idea is that visualization is not limited to a graphical way or a function, like a special function for a bar chart, for example. So our representation is composed as a combination of these different building blocks. Similar to a language, so metaphorically speaking, we combine words with the rules of grammar to form a sentence. On the right-hand side, we see some code, and on the left, we see the levels of grammar. And if we go through the lines, we see that it's very easy to do a plot. So we start with our data set cars, then we decide what to mark points. That point should be used as a mark. And then we point out what belongs on the axis. And in the end, there's a small transformation. So we set a filter. What we notice is that the scaling as well as the guide are added automatically. So Altair does its thing and knows how data could look best. Let's compare to other graphic libraries. So other graphic libraries, they require often a different way of thinking, or they take you away from this grammar. So compared to Matplotlib, which is usually really straightforward and flexible enough to be to do every plot if you put in a little effort. But yeah, as soon as you start with statistical visualization or want to do some data exploration, Matplotlib can be a bit complicated. As you can see, we have a similar scatter plot like we had before. But you have to start defining a color map. You have to do this group by, and you have colors for each origin. You have to scatter each individual group. And all of this is still doable and understandable. But let's say you want to plot your data into a matrix of panels. So each panel shows a different subset of your data. For example, blue, green, and red dots have their own graph. So what you end up doing is you're starting to mix together the origin names with the subplots, the axes. You have to keep track of indices. You have to make sure you're drawing the right axis and things like this. So the fundamental challenge is that we are mixing what we want to do with kind of mechanics of how we are going to do it. And this is where Altair comes in. So now we hand it over to our Jupyter notebooks. And here's an example of using the Altair API. First, I have to load up a few things we've seen in the graphic. And this is the thing we are going to build today, an interactive scatter plot. It's very cool to be able to quickly visualize the data set. So like I said, the key idea is that you're declaring links between data columns and visual encoding channels, such as the x-axis and the y-axis. So we're going to install it now. So to work with it, it must be installed, obviously. We do this by writing the following line of code, pip install Altair, and we also load up a Vega datasets, example set of data that we will work with today. And yeah, we will load up our libraries, Altair's alt and Vega dataset as data. And we have a dataset of classical cars here. We can see the names, the horsepower, the respective year, the origin. And then we can start with our first visualization. So usually a dataset like this is a very good start to show the capabilities. And now we want to start. We type in alt.chart. We decide to use points here, and we simply we have to declare what data frame we are using. So in our case, it's cars, and we can see a point. And to be exact, that's 406 points stacked on top of each other because Altair doesn't know the encoding channel yet. Like I said in the beginning, encoding is a way to map visual elements to a chart. So we define what elements are on the respective axis and what colors, for example, the axis should have, the points should have. So we add a column on the x equals horsepower. So now we can see the horsepower, which are now spread on the x-axis, the points we had before. We can do things differently. For example, we can do tick marks. So we copy our line of code and replace the point with tick. So we can see the range of our data set in terms of horsepower a bit better. So as we can see, it's a bit more useful, but it's still not the most useful information to say. So we can build on this and we can break this information down further by saying we want another axis. So we add the origin axis so we can see the ranges of horsepower of each respective country. We do that by saying y equals origin. And yeah, we can build a scatter plot now by doing alt.chart cars. We use points, obviously, for a scatter plot. And we do the encoding. On the x-axis, there's horsepower. And on the y-axis, there will be miles per gallon. By doing that, we will see the links between the two. We decide to color these by origin. As you can see, we use the building blocks of the columns of our data frame, and we add up with a scatter plot. And that's how easily we went from a one-dimensional graph to a two-dimensional colored scatter plot. Altair automatically adds the chart legend and handles the scaling for us. So, like I said in the beginning, it's all about thinking in building blocks, grammatically thinking to create a chart. So we can also build bin data. That's something that's very useful in data visualization to make histograms, for example. So in order to do that, we can simply copy our lines of code we had here, and we type in bin equals true. And as we can see, this doesn't work. Because if you add a few more arguments in your encoding, you have to write alt.x or alt.y. So we write alt.x, horsepower bin equals true. So what we are doing is we are binning the data and we are ending up with this graph. This is not very helpful yet, but we see the binned data. So if you copy that and do another small function on the y-axis. This function is called counts. So we count the respective values and we end up with tick marks that represent the counts to each binned horsepower data. Because it's hard to see, we change the mark to a bar chart And as you can see, we end up with a histogram. So what's cool about Altair is that histograms or heat maps are not tied to a special function. These plots arise through our information that we provide. So like I said, it's not tied, so we can even go further with a two-dimensional histogram by simply adding another axis. So we just add the y-axis, and we do that by saying alt.y miles per gallon, and we set the color as count, and you will see why we did that. Okay, this is not true because I have forgot to bin my data on the y-axis. Bin equals true, and what we end up now is a heat map. What's super cool is that you don't have to remember the syntax or special commands to end up with visualizations like this. You simply think about how your data should look like. So we take those building blocks and insert them into Altair. So that's the key idea of declarative grammar. We then try to do a bar chart. We've learned how to use the count function. We can create a simple bar chart to count how many cars are from each country in our data set. Do that by alt.chart cars marked by in code. On the x-axis there's the origin, and on the y-axis there's count origin. We add a tooltip, so that's some information that if we hover with our mouse above the data points, we can see more information that we provide now. So we can see the origin and the count of origin. We can try to set this up interactively. So we do that by typing in .interactive, and we plot this. Now you can see there's a bar chart, not very special, but like I said, you can see the information of each country. What's cool is that if you want to change from a horizontal to a vertical bar chart or change things, you don't have to change the type. So basically, you just swap the channels in the encoding. So we copy our code, we call that bars, so we can give it a name. Like I said, we will change the axis from y to x, and we will color this, add a color equals origin, and if we run this, we have to call it, of course, bars, and we can see we have a new bar chart that is now on the other axis. So we can combine multiple plots. That's also very easy. We have this scatter plot we had before and the bar chart. And we can easily combine the two charts by adding a plus sign, an and sign, or a vertical bar. So we do that by scatter plot, vertical bar, and bars. And if we press run, we can see that they are next to each other. We can change that to an and they're below each other. So, and you can also do plus, which layers them on top of each other. This doesn't make more sense, but it's helpful for other fix, and it's easy to do that, as you can see. So now we are going to do make graphs interactive. We've shown that before, but we haven't shown the interactive feature yet. So we add a tooltip, so we can see if we hover above the data points. So we end up with more information. Very helpful in my opinion. And we do things interactive by adding interactive at the end. So what we can do now is we can zoom in, and we can zoom in on single data points and see the information. Zoom out, as you can see. If you remember what we said, it's about plotting your data in using building blocks. Super easy to do. Impressive things like this. And now we are going to do plotting data in a matrix of panels, this can get tricky in Matplotlib, as we saw. And this is super easy in Altair. You just add the encoding column equals origin, and we end up with the respective data points from our data set. The graphic is a bit big, so what we are going to do is we make things smaller by adding properties. You can do that by adding dot properties, and we say that the width is equals 200 and the height is 150. So things get a bit smaller. Easy as that. Right, so let's run this. You can see we have a plot here. And if you are familiar with Plotly, you think, oh, okay, Plotly is also very easy, also very declarative. But Plotly syntax is more focused on having individual function for each plot. As you can see, we have a function called scatter, and these functions take several parameters to control the behavior. And Altair, on the other hand, focuses on having a graphical grammar. When you compose charts, can use those units. What's also easier in Altair is to combine two charts like we've seen before. So you do this by plus, and it's not that straightforward in Plotly. So like I said in the beginning, we are going to build this interactive chart. And we learned almost anything to build this graph here. So like I said, it's similar to building blocks. There's also a grammar of interaction that allows us to build things like this. So what we are going to do is we are copying the scatter plot. And after that, we are adding an interval. So copying, and we are saying interval equals alt.selection type equals interval. And now we have this, and we add this to the chart right here. We can say properties like we've seen with the size before, and the selection equals to our interval. So let's run this. And as you can see, we have this little box that can move around. We can use this to our benefit because every time we move this box, Altair knows that our selection has changed. So what's cool is we can link properties to chart conditions. So we can link this to our selection. Like I said, we link chart properties. So we change our color based on our condition, based on our interval. So if it's inside the box, it's the origin color. And if it's outside, it's alt.value, light gray. We have to write alt.value because otherwise Altair thinks that this is a column inside of our data frame. And since this is not true, we have to state that this is a color, not a column. So we link properties to the charts, conditioning to our selection. We call this points. We have the interval, and we have to call points. And what we can see now is that our selection is, what's inside the selection is colored, and what's outside is gray. So you can click around to the points inside, and those are an origin color. And by doing that, we can now simply do multi-panel charts. So both have that selection tied to them, So we simply copy our code again. We say interval. We write down the bar chart we had before. And now we tie the selection to both of them. So like this mark bar. So y equals origin, color equals origin, like we had before. And the x is count function origin. We've seen before how to show two plots next to each other. We do that now below each other. It's a bit better. We now try to link them. They're not linked yet. So that the selection we do in our box is linked to the bars. So we do that by simply saying transform and underscore filter and interval. And now our bar chart is also linked to our selection. And we have now this super cool interactive plot, very impressive in my opinion. So it's just a few lines of code, like we've seen before. It's just built on those building blocks, can be done very easily. So that's about it. I hope you learned something. I hope you will use Altair in the future. If you have further questions, look up in the documentation. There are a few case studies similar to ours. And now you are able to do cool plots very easily without thinking a lot of the syntax. And I hope you had fun and enjoy this one. Peace.